Welcome to our monsol monitoring system. It is very easy to access. All you have to do is to go to www.monsol.net and click the demo icon on the left. We have just accessed the total control mode, which enables you to see all the available functions of the application. First of all, let us see how to register a new application user, clicking on the @ symbol in the bottom right-hand corner. What you have to do is to fill in his or her name, the telephone number, and select the type of access and the extent of authorization of the user. Then you check or uncheck the option to receive text or email notifications and select their language. Monsol monitoring system is so far working in 7 languages. That is, the maintenance staff, for instance, can work in one language and the investor and the engineers in another. Let us proceed to another icon which enables us to see and modify the main features and characteristics of the power plant. The most important section here is the tariff section. The modification of the tariff is directly and automatically reflected in the invoicing section. The third icon in the bottom right-hand corner is the access to a window that enables us to upload, download and generally share files of all types with all the different users. It is extremely useful to share all technical information and as-built drawings and make them available for all users anywhere, anytime. Clicking on the image on the main page, you can view a schematic drawing of the power plant. The system generates alerts as soon as something on the plan isn't working the way it should. These events, as we call them, occur, for instance, when production of the strings of the inverter or the energy meter is below its potential given the current radiation. Unfortunately, there is currently no alert in our demo application. So let us see a real power plant monitoring. As you can see, there is currently no active alert. Nevertheless, entering the event history section, we can see that there have been some communication failures this morning. This is quite common as this is when the inverters start up. All the failures are listed here in the events history section. Should this failure remain listed for more than 30 minutes, it is no longer considered an event and it becomes an alert. This alerts list contains failures unresolved for more than 30 minutes. For instance, here we can see that 5 out of 8 inverters are not working properly. This failure is actually not very important because it is caused by a defective fan. Here, however, we can see that there is a relevant communication failure of bus cable number 2, which connects to the energy meters. As we can see, the problem has been unresolved for quite a long time. Since we're working in the total control mode, we are allowed to configure the different alerts. You can turn them on or off, include their operation in maintenance tasks automatically, check or uncheck whether they affect the general availability, and have a notification sent to your email or mobile phone. Not only can you view the alerts by groups, you can also view all the devices at once and set them separately. In this plant, there are more than 3,000 devices and you can activate or deactivate any one of them. All this information can be exported to Excel and can be printed in PDF format. This brings me to the end of the introduction of this section of alerts and events. Let us proceed with the demo application. We have seen how alerts and events work. Now let us have a look at the power plant report. Similarly to most of the features of our application, the power plant report is configurable. In the default configurations, there are 7 columns, the most important being the date, of course, since the report is generated the following day. It is a summary of what happened yesterday. In this column there is information on performance ratio, availability, yesterday's radiation and production. Afterwards, there are values of radiation and production as related to the performance ratio. At the same time, there is the overall production, deducting consumption or some kind of coefficient. This is also configurable. On the bottom line, there are average or aggregate values from the last 30 days, but it is very easy to display data from, say, the first day of this month or last week, and to see what is the last week's production, last week's average performance ratio, availability, and all this information can be exported to a PDF. Let us now proceed to the graphs module. This module contains two phases. The first one is a straight line standard phase. You simply select the component you want to work with, inverter, weather station, power grid analyzer or energy meter. Any measurable component will be included here in the graphs module. Now we have selected an inverter, one of its power stages, and a string combiner. The graph is displayed so fast because the database is divided into two parts: recent data and data older than 45 days. If you wish to display data older than 45 days, it takes slightly longer. You can zoom the graph in easily with the right double click. Following the graph line with the cursor, you can observe all the values. You can display or hide any of the data lines. And you can also modify the interval between the data points. You can shorten the interval from 10 minutes to 5, for example. The program is intelligent, and the higher the number of days you wish to display, the longer the interval of the displayed data. Still, it can be always modified, and even though the default interval, say, is 30 minutes, you can always shorten it down to 3 minutes, if you wish. You can also modify the hours of the day you would like to display. In the default configuration, it's from 5 AM to 9 PM, but you can set any part of the day you wish to. And then you click the refresh button, either this green one on the right or this one at the bottom. Depending on the components displayed, you can always select an option from this list and view data related to this component. Let us view the power, for example. When radiation line is displayed, you can select one of the probes and compare it with the electric power data. You can select the closest probe, an inclined or horizontal probe, depending on the type of your weather station. You can view all this in straight lines, or, clicking on the icon of Advanced Graphs, you can make a multiple selection of what you want to see. I have just selected 3 different power stages of 3 different inverters and a power grid analyzer. Inside the power stage, I will select a string combiner, and inside the string combiner I will select a string and add the radiation line. You will see this note if you combine components that have little in common. What you want to see is a coherent graph, so be careful and select just the relevant components. Data is now being downloaded directly from the online server where all the data is stored. It is collected locally in the power plant where our local monitoring program is installed. It collects the data, organizes it, calculates the average, minute, maximum and minimum values, the performance ratio, and all these results are replicated to the server. The speed of the graph calculation also depends on the speed of your internet connection. Again, you can display or hide graph lines as you wish. And depending on the components displayed below, you can select the option you would like to view. All this data can be exported to Excel. You select your desired interval and hours of the day, and all these personal settings will be reflected in your Excel sheet. It is therefore extremely comfortable to get visual data on the one hand and numeric data in your Excel sheet on the other. What we're seeing now is the statistics module. It is very useful as it compares the different comparable components with each other. Here, we're comparing the different power stages of the different inverters. Clicking on any of them enables you to see the values of the component in comparison with the average values. It displays the values of today, yesterday, last 7 days, and last 30 days. The chart shows which of the components is producing the most today and which one is producing the least. It calculates the average value, it orders the components by their percentual compliance with the average value, and those components that are more than 15% below the average production are marked in red. Similarly, you can view all other components, be it inverters, power grid analyzers, or energy meters. Analyzing inverters is extremely useful because it enables you to analyze the strings. You can select a string combiner and you can observe the values of all strings it combines compared one with another. Obviously, you can also set the time period you wish, and it is all exportable to Excel. Let us now proceed to the availability section. As we have already mentioned, in this demo version there are no events or alerts, and therefore this power plant is always working 100%. Let us see the real power plant again. We can see that there has been no failure of any kind yesterday, but switching to another date, we can see that there were some problems. This is how we calculate the availability. We suppose that 200 watts per square meter is the threshold value. With this amount of radiation, all components must be working 100%. Should there be a component that is not working for more than 10 or 15 minutes, this value is configurable, the system generates an alert. This alert takes away a certain amount of photovoltaic time of the corresponding component. Let us have a look at the strings, for example. We can see that there are many strings that interrupted their operation at one time of the day or another. The disruptions, however, didn't last longer than 10 minutes. They could be caused by a shade or by a failure of an inverter. It is useful to have this information, but as we can see, it doesn't affect the availability. One of the strings that has affected the availability is this one, string number 1 of string combiner 5 of inverter 1 in transformer station 1. It was off on the 25th of September from 17:28 to 17:42, that is 13 minutes. Together with other defective strings, it has affected the overall availability by a relatively small portion, considering that this is an 8 megawatt power plant. It seems that an inverter was off for some time, namely for 44 minutes, the third inverter from the top. All these disruptions have affected the overall availability of the power plant. Again, everything can be exported to Excel or converted to a PDF. Let us proceed to the preventive physical maintenance module in our demo power plant. Since we're working in the total control mode, we can create a working group. These two icons are not accessible outside the mode of total control. Let us name the new group presentation, the code, which is a mandatory field, say PS, number of workers. You can also describe its function, say presentation. The boxes below indicate the working days of the group, be it the whole week or business days only. On the right, you assign a power plant to the group and click to save the changes. Now let us go back and assign a task to this group. There are 276 default tasks included in the system. To assign one of the ready-made tasks, you simply click on the Edit icon and assign it to the desired working group, which in this case is the group Presentation that we have created. We're not going to do this because we're going to create a brand new task, clicking on the plus icon on the right. Say the name of this task is Web, and the description of the task is a video presentation. We will assign this task to the group we have created. Automatically it sets the number of workers, and afterwards you assign the device, periodicity, duration, and finally you save the task. Now you can find the task listed below, as these items are listed alphabetically. So we have now created a working group as well as the task. Now, coming back to the main preventive maintenance menu, you can access your maintenance schedule. The dark grey line separates the assigned tasks from those that are not assigned. You can order the tasks alphabetically. The assigned and not assigned task, however, will remain separated. Now, scrolling down to the letter W for web, you can click on the white box, which means you would like to accomplish this task this month, but do not know the exact dates. These boxes turn blue, which means they're planned, but not confirmed, unless you can confirm them. In this case, you click on the grey part of the box and assign the corresponding dates, be it 1 day or more. If you select a day in which the group is not working, this error note appears. This chart is divided horizontally so that you could see the different tasks, but also vertically so that you could plan, for example, the whole month of September. This monthly schedule, as we can see, now contains the task called Web that we have arranged for the 28th of September. You can easily grab the task and schedule it for another day, let's say today. Similarly, you can grab a yesterday's task and schedule it for today. Double-clicking on the task, you can view the working group responsible and the description. Double-clicking on the day, you can check or uncheck tasks that should be accomplished that day or that month. They might be scheduled for another day of the month or not scheduled at all. All this can be exported to PDF or Excel. Let us go back to the yearly schedule, which remains unchanged because we have only made some modifications in the monthly planning. The only thing that has changed is that our task called the Web is now listed above the dark grey line among the other assigned tasks, and it is red because the day of its accomplishment is close. Now, coming back to the main physical maintenance page, which is the one that my maintenance workers can access. I have drawn the task that wasn't accomplished yesterday to today, and this is the task that I created and scheduled for today too. That is, all the tasks that are scheduled in your agenda are displayed here for your workers to see. You can double-click and make a comment. Say, the task has been accomplished successfully. You can also attach a photo, an invoice, or any other file to send to your worker. And at the same time, you can check that the task has been accomplished. In the mode of total control that we're working in, you can also delete the task. You can save your changes clicking on the icon on the right. On the main page, we can see that the task is commented on and accomplished. Now, coming back to your yearly agenda, refreshing it, you can see that the third task from the top, that is the task we have just modified, is marked as accomplished. Similarly, you modify the task called Web. Check the accomplished box, save the task, and click on the refresh button in your agenda. Now you can see the task marked as green, which means it is accomplished. Now, converting this data into a PDF file, you have a neat maintenance report of the accomplished, unaccomplished, and scheduled tasks, or tasks that were scheduled for this month but have not been assigned a date yet. You can also delete tasks simply by double-clicking. Now, coming back to the real power plant, these are the alerts that were generated on the plant yesterday. All these alerts are automatically incorporated into your list of preventive maintenance tasks. That is, both corrective and preventive tasks are listed in one sheet. You can also add an extra task, which is neither corrective nor preventive, simply by clicking on the plus icon. This yellow icon opens a simple accountancy program. Here on the bottom you can add suppliers, new families or costs. Here you can see which maintenance costs are related to the corresponding power plant. The second yellow icon opens the stock control tool. Then there is a monthly maintenance report, which is very comprehensive and will be divided into 3 parts that will be downloadable separately. You can comment on this report, but you cannot modify it because the data you obtain is the data you have. This brings us to the end of the maintenance module, so let us proceed to the invoicing. Since we monitor energy meters, the values we have are exactly the same as those of the electric power distributor because we are reading from the same device. The PDF invoice is issued automatically every month, but you can open it with Excel and modify it. Now let's continue to see the trackers module. There is a lot of useful data here, such as information on the motors, information about the trackers. You can see if the panels are in the defense or tracking position, information on the wind speed, etc. The tracking system will be updated in the upcoming version of the program Monsol V9. This icon opens a section with the live webcam coverage of the power plant. Please note that this is only a demo version with a demo image. Last but not least, there is the weather station module, which enables you to see the weather values directly. You can also view them through the graphs module, but we thought that direct access is much more comfortable. Now let us see the left section of the application. This is a graphic representation of the whole power plant. This is a 2 megawatt installation with 2 transformer stations and 2 500 kilowatt inverters in each of the stations. These 3 icons stand for the power, the money and CO2 emissions or performance ratio. They are all configurable. Below you select the number of days the information relates to, or you can also select a specific period of time in the calendar. In this way, you can comfortably find the average performance ratio, the aggregate energy produced, and the energy generated by all of these devices in the selected period of time. Clicking on any of the graphic icons in the left column, you can display the complete diagram. On the right, from the inverter being all the components the current flows into, and on the left being all the components that send energy into the inverter. If you enter one of the power stages, you can see its performance together with its internal alerts and more information. You can extend this information by various days. You can get average values calculated for this period of time. For every single category, this inverter is able to measure. These shortcuts at the bottom open graphs or statistics related to this inverter or export all data to a PDF. Very briefly, we will have a look at some more examples. You can display string combiners that send energy to this inverter. You can enter any of the combiners and see exactly what is the production of the different strings. You can see the string that produces the most and the one that produces the least. And entering any of them, you can see its production related to a selected period of time. All this can be exported to Excel. Similarly, you can view the rest of the components, be it the power grid analyzer, transformer station, distribution center, or the energy meter, which are the most commonly monitored components. It is not a problem to include more components or to remove some. As I have already mentioned, all the information is collected, ordered and organized by our system in a specific way so that the program installed on the server could access it and read it. Once the information is organized the way we need, in the default configuration it is automatically included into a single control center. That is, you can control all your power plants with one single application. For example, this is a unified control center with about 30 different power plants. You can view it in the geographic mode or in the control center mode. Here you can display all the installations that we control 24 hours a day. You can also filter the power plants. Now, only the data related to these filtered power plants will be included in the application. You can see this immediately on the map and also in the different reports. These power plants, unfortunately, do not dispose of radiation probes, and therefore we can only monitor data from the energy meter. That's why there's no availability or performance ratio. Even though there are currently no values, we can still display the availability module, the maintenance module, weather station, language setting, etc. This control center can include not only power plants monitored by Monsol, but also any other power plant monitored by any other company. The only thing that must be modified is the data generated by your program for data acquisition and converted into our format. Once this is done, you can automatically access your data through our application.